Next talk will be given by Gourav Takhar on memory safety verification of open programs with Angelic assumptions.
So I would like to start with a question that this program strncpy, which copies n strings from source to destination, does it violate memory safety properties? So as we can see here, it will violate this property at multiple locations. So it will give us errors at line 4, line 6 and line 8. And for each of these cases, suppose if the SRC is pointing to a string which does not contain null character, then also it will give error at line 4. And if the size of the destination is smaller than the size of the string which SRC is pointing at, and it is also less than n, then also it will give an error at line 6 and line 8. But when these functions are called in complete programs, we assume that SRC, whenever these functions are called, SRC is always pointing to a null terminated string, and the size of the destination is of length n. But when we give this function to a verifier, it will have demonic behavior. It will assume that the inputs can take any value. So in that case, it will give us these these errors at multiple locations. So these kind of programs where we don't have any information about the environment, these are called open programs. And these inherent assumptions about these functions, whenever we are calling, we call them angelic assumptions. But since the verifier doesn't have these assumptions, it will give us many false positives. So it decreases the confidence of the tester or programmer, and they are not able to trust whether the error that verifier has given, it is actually correct or not. Right? These are false positives. So they tend to ignore them. So my talk is on automating generation of these angelic assumptions for these open programs and verifying them for memory safety properties. This work was done in conjunction with Baldip from IIT Kanpur, Prantik, who is working at MathWorks, Akash from MSR India, and my supervisor Subhajit from IIT Kanpur. So formally, what we want is that given a program P and some user given assumptions about this program, we have to synthesize an angelic assumption set such that when we verify it for memory safety properties, we are able to suppress most of these false positives. But if there are any true positive, we do not want to suppress them. So we divide our approach into two parts. One is that we try to find out some patterns about these angelic assumptions which we make, and these templates are done using LLM to find out the idiomatic patterns which are commonly used in these programs. And the second part is that using this template to actually synthesize the angelic assumptions. So first part is how do we use LLM to find out these idiomatic patterns of for memory safety programs. So first we ask the LLM to generate more than like in our case we ask LLM to generate more than 1900 programs which does these buffer manipulations. For each of these functions, then we collect what are the inherent assumptions for these functions. We generalize these assumptions, and from these assumptions we extract what are the idiomatic patterns which are being used here, and we shortlist them based on what are the more frequent patterns, and these patterns are then given to the verifiers, experts. Then they can see that whether these assumptions patterns make sense or not. So from these templates, from these patterns, we come up with these 7 assumption templates. So first is the null terminated string. So suppose if P is a pointer, then there is at least one memory location where a null character is stored in this, right? So, for example is that strlen and strncpy. So, these kind of functions assume that this str or src, they point to null terminated strings. Another is the non-overlapping buffers. So, if there are multiple arguments, multiple pointers, then we don't want that the buffers they are pointing to, they should not overlap with each other. And similarly, there were other templates which we found out, which we used in our experiments. Okay, so now we have got these templates. The next step is, can we use these templates to synthesize the Angelic assumptions? So let us take the same example and go over like how do we generate these assumptions. For this strncpy is the same function. First, we instrument it for memory safety properties, and the instrumented code is then given to the verifier, which gives an error trace. So here in this case, it found out okay, there is an error at line 4, and this error trace is then given to this weakest liberal precondition synthesizer. So this this gives us a weakest precondition such that this error should be suppressed now. Now, using this weakest precondition, we try to come up with a Angelic assumption based on those templates, such that whenever that Angelic assumption is true, this weakest liberal precondition will also be satisfied. If we are able to synthesize, so which is the case here, we get that src should be a null terminated string. In that case, we again go to the verifier and we again try to verify with this assumption. So in the next iteration, it comes up with another error. So it finds out that okay, even if we give this assumption, there is an error at line 5. So for this again, we go through the same process. We again generate the weakest precondition, and again we are able to synthesize that if the size of the destination is equal to n, then it will always suppress this error, right? Then again we go to the verifier, but now there are no more errors. So it returns as okay, this is a false positive. It will give us a list of all the errors that it encountered, and it will classify them as false positives with the assumptions that were used to suppress them. But if we are not able to synthesize any these assumptions in any case, then we identify them, okay, these are the true positives, so these are the actual errors, and they are given to the user. Okay. So we evaluate our work on like 182 open benchmarks taken from VeriSec benchmark suite, which is commonly used for memory safety verification. Here we classify these into two categories. One is the safe open programs, where if there is no true positive error, so all errors should be suppressed in this case, and unsafe programs where at least there is one error trace that should not be suppressed, that is an actual error. Okay. When we evaluated, we found out that no unsafe program was declared as safe, meaning there were no true negatives, true positives which were classified as false positives. And we were able to suppress more than 75% of the false positives. We also compared with the existing tools like Angelic AV, where like AV is designed for bugs like divide by 0 or null pointer. So, but it is not designed for memory safety properties. So, we can see it in the results also. So, for the unsafe benchmark, it shows that total number of the red part is the total number of counterexamples encountered, and the blue part is the number of counterexamples suppressed by these tools. So, here we can see that in case of unsafe benchmark, both of them perform similarly, and they are not suppressing most of the bugs. But in case of safe benchmarks, where most of them are false positives, we can see that Seeker is able to suppress most of these bugs. But AV is not able to do that. Okay, thank you. Any questions?
We have time for questions. If you have questions, please walk up to the mic and ask the questions. So, one question I had is, can you handle dynamic memory allocation, malloc and free? If I have two buffers that are newly allocated, can you synthesize? Can your system?
Yes, we can handle that.
Okay. So what about programs? So you're assuming your notion of true and false positives, right? They are based on the Angelic invariants that you infer, right?
Yeah, Angelic assumptions. Yes.
So how do you know that they are correct?
So our Angelic assumptions are based on like what is commonly used, like what is in practice, right? What the programmers use. So these idiomatic patterns are we give them to the verifier also as a warning that okay, if some counter error trace was there, so we will also give okay, this assumption was used to suppress this. Then the user can see whether it is reasonable or not.
Okay. Yeah. So these are very standard. These are the assumptions that other systems also make.
Yes.
Okay. Any other questions from the room? If not, let's thank the speaker again.